1.
All right, so I made a quick tutorial video for you to understand kind of what is needed for the potluck and the potluck presentation. So the potluck presentation is not necessarily a presentation. It's just a digital document that is housing all of your evidence for knowledge about the stuff that you're making. So it could be a Google slide, kind of like what I've created. It could be a Google Doc. It could be anything, really. It could be a website. It doesn't matter, but it needs to have the information that I'm about to go over. So the first objective would be your background, the why, and the food objective. This is really easy. Like, in order to get mastery, you need 4 things. The first thing you need to do is tell me what you're making. So what is it? Why did you choose it? Is it a family recipe? Is it something that you just like to make? Maybe it's just something you like to eat, okay? But just for A, just what did you do? Why did you choose it? For B, provide the recipe. This is really important that you have the recipe and you have the ingredients. Actually, this is what is going to be showing to everyone when we do the potluck, because we need to be aware that there are allergy issues. So you need to have all of your ingredients listed and making sure that everyone can see those ingredients as well. Remember, this is something that you've made from scratch, so you should know exactly what's in there. See, what safety precautions did you have to use? If you're cooking, baking, doing anything in the kitchen, there are definitely some safety issues that we have and we have to be aware of. So make sure you state those. And last but not least, D, you won't be able to do this until the potluck, but make sure your food is present. You can't get mastery if you don't have food there. So making sure you bring your food in to share for everyone. And then just make sure, again, less is more as far as like portion size. The smaller you make it, the better. We just want people to have a taste. If there's more, they can always come back for that. All right, so here's what you need to do. Once you figure out what you're doing, then you have to do some research. So I did, just as an example, because no one's going to be doing this, I did the reaction of baking soda and vinegar. Now, if you do a reaction that's in cake or frying or anything like that, you're going to have to search that out. And I'll talk about if you're stuck in the next slide. But here's mine. So I went to Google and I searched baking soda reaction vinegar equation, baking soda vinegar reaction equation. And this is what I came up with. Okay. I did not come up with this at all. This is the reaction equation. So when you do this, you're researching an equation and you're using that equation. So this is vinegar. This is baking soda. They react to form sodium acetate. That's what that is. Carbon dioxide and water. Okay. Again, I found this right off the internet. I just had to figure out what that reaction was. So you have to figure out what your reaction is. Okay. Is it the decomposition of baking soda or baking powder? Because you have some sort of cake, or if you have some sort of pie, pie wouldn't be a normal one. Anything like that. Okay. So evidence. You need 3 pieces of evidence here. You need to identify and record a chemical reaction that is taking place in your recipe. There might be more than one, but you only have to choose one, okay? You're going to label the reactants and products in the chemical reaction. I did not do that here because I didn't want to give the answer away. It's pretty easy. And then also provide evidence based on your observations that a reaction occurs. So I didn't do that here either, but you would say, for me, the reaction occurred because when I put the baking soda and vinegar together, I got bubbles, which means production of gas, and that is a chemical reaction. Okay, so I kind of skipped this first because you got to figure out what your reaction is first. Okay, so 3.1a would be your first step, is doing that research. Now, if you are struggling with finding a reaction, then ask. Okay, some of these can be hard. Some of they can be hard to find, hard to understand, and that's why we're here to help you. Okay, so ask your teacher. Now, if you're doing a reaction that involves browning, which would be grilling, frying, caramelization, making caramel, anything like that, that is a Maillard reaction. There's more information about the Maillard reaction in the potluck folder on Schoology. Again, this is a hard reaction, so find your teacher, ask them to help you, but you'll be able to find that reaction. We found it for you. Okay, so that's if you are struggling. Now, 3.1b, we have our chemical reaction, and the next thing that we need to do, and we have to figure out why this follows the law of conservation of matter. Okay, so we did this in class. Why do we have this equation, and how can we say that the atoms follow the law of conservation of matter? And then for B, obviously, so this would be for A, it's more of like theoretical. Why does it follow it? Why does this equation follow that? B is more, well, if we actually make the cake or do whatever, what steps or special procedures would we need to do to follow the recipe so that my initial mass is equal to my ending mass? So if you think back to when you guys did your Law of Conservation Mass Lab, well, we had a closed system, right? We had a plastic bag, okay? We would not be able to have the baking soda vinegar to be equal in mass if we didn't have that closed system. So you need to talk about how you would create an environment that you could have the same mass from what you started to what you ended. All right, now we are back to 2.1. So again, I've skipped around because you needed the equation before you can do 2.1. So for 2.1, what you're going to do is you're going to identify all the ionic and covalent bonds in here. Okay, so you can see here, I've labeled it. You can do it any other way, but this is the easiest way that I found for me to display that. Okay, so just keeping in mind, just remember for our purposes, carbon bonds covalently, and then also hydrogen, we're going to talk about bonds covalently too. And then the last thing, exothermic versus endothermic reactions. Okay, so I have my equation. And then what I'm going to do is I have to put heat in my reaction. Well, if I know this is endothermic, I know I have to put heat in the reactant side. So in order to start my reaction. And then I have to go back and I have to then explain this. So my explanation is this reaction is an endothermic reaction because there is a decrease in temperature after the reaction occurred. Heat is needed to start this reaction. In the instant when you mix these two, the heat is taken in from the surroundings, from the air around the reaction, which then starts it, causing the reaction to occur. Okay, so again, yours is probably going to be different. Okay, so what is your reaction? Explain that, and then also put heat in your equation, very similar to what you did in your endothermic exothermic lab. Okay, so this is all that you need to do. So if you look at my project, I guess my sample project was 6 slides. Okay, that's because I did mine on Google Slides, but again, it could be a Google Doc. It doesn't matter. So choose what you want, and if you have questions, let us know. Good luck.